Hello everybody. This project I kind of already started, but I figured I might as well film it, especially given I'm supposed to be releasing a video in like a day and a bit, and I haven't filmed anything yet. Very simple project. I scribbled out a schematic here. This is a non-contact voltage detector. I will get into a second why I have some issues with these, but they are useful, hence why I'm building one. The way this works is very simple. This over here is an antenna. It will pick up the fields from an AC wire. So when an AC current is in a wire, it will create a magnetic field around that wire, which this will detect, and that will cause a very tiny current flow into the base of this transistor. This transistor will then amplify that current and cause a larger current to flow through here, which we're going to hear, and so on until you end up with this transistor hopefully being turned all the way on. We then have a resistor and an LED, and that's it, that's all that happened. So when you put this coil near a live conductor, this LED will come on and tell you that conductor is live. Now, the issue with these is major, and that is that they are terrible. They're very inaccurate, they provide false negatives, false positives, they're just overall extremely unreliable. The reason I have one, the reason that most people have one, is it's very good for if you want to just, is this live, yes, no. If you want to go, is this live because I'm going to work on it, these are absolutely not suitable. They should never be used to prove isolation. They're just basically an indicator. Anyway, I need one for my new tool bag I was just putting together there, so I figured I would build one rather than buy one because they are so simple. Without the way, I'm going to get on to how I'm going to do this. I'm just going to do it with whatever junk I had lying around, so hopefully you'll be able to replicate this. 1 second while I go and grab a couple of things. So these are all the parts I'm going to use. For the case of this, which is the hardest thing to do, most of the other ones I've built, I have one. Most of the other ones I've built previously, I think it's one of the first ones I built, are like this, which are just, they're fine, they do work, but not particularly toolbox friendly. So I want to make one in a case. I have this case here, which I'm going to use. This is the metal tube from a certain device I'm not going to say the name of, which are actually now illegal in the UK. I think you can't buy them anymore. But I used to pick these up off the street all the time. I have rather a lot of them, so I used a bit of the tube, which is the handle for these devices, in order to use for the case. I have a cell which is also salvaged from one of the devices too. This is not the same device, but same function. This is a coil I've made, just wrapped a bit of, I think this is 2.5mm, it looks like, cable random wire I had lying around on my desk. I formed it by wrapping it around a tube from another one of those certain devices, different model, but just wrapped it around the tube to form a coil. I have here as well, this board on the top is a TP4057 board, which is a lithium charge controller for the cell. I have attached with some double-sided tape to the top of this button, and this button here is just a standard industrial panel button, which I happen to have a big bag of these lying around, so I was going to use this. This button is illuminated, so I have already taken it apart, as you can probably see by the small gap where it has not gone back together quite properly. But I have taken this apart, I have replaced the resistor inside, so this will run on the lower voltage now. And I'm going to use this as both the LED and the power button. And then, of course, I have here 3 BC337 transistors. You could use basically any signal transistor. These are just what I happen to have in large quantities. So with that out of the way, I'm going to get on to the assembly. This is very straightforward. Pretty much anyone could do this. So one moment while I get on with that. So I have assembled this here. I have the red wire for the positive, which goes to the common collectors. I have the emitter of the last one coming out here on this yellow and black wire, which is going to be my switch negative, which is going to feed this, or sorry, my switch positive, which is going to feed this. have the 3 here connected with the base of the first one onto the end of this, and the other end of that wire is just capped off with a bit of hot glue. I'm going to then cover all of this in hot glue just to stabilise it, but I wanted to show you before I do all that. So I have had a bit of a design change. This is the same, I just put this coil on a longer bit of wire for testing purposes. We still have the 3 Darlington trio here, but because these transistors I think must have been from the bad batch I got a while ago, and I've been trying to use up, the HFE on these is not what it should be, it's below spec. What that basically means for people who are not very familiar with electronics, the HFE of the transistor is the DC current gain. So for these, the HFE should be 180-ish, which means if I put 1 milliamp in the base, I get 180 milliamps of flow from collector to emitter. These ones is much lower, I can't remember what it is, but it is significantly below that. So this was not functioning with only 3. So what I have done is I've left those 3 there, and I have put a good branded transistor here on the negative leg of this, which is much higher gain. This is a gain of I think 300 and something. So the small signal coming out of here is then going into here, and that's switching the current for the LED. I disassembled this again and have removed the resistors from inside the button entirely and replaced it with this 22 ohm resistor here. Other than that, everything else is the same. We have the battery feeding the control board, which is then the negative of that is going to the transistor. The positive comes to the contact of the switch, goes through one side of that, feeds the lamp, and the other side of that goes into the positive of here. I'm going to now glue this together and I will show you it working. I figured I would just show you here before I put it together. Basically with these, when you put the coil near a live wire like the flex on my hot glue gun, the light comes on. When you take it away, the light goes off. This one is now a bit too sensitive, but you can see the approximate idea. These, as I will stress again, I don't particularly like using these much because they are prone to give false positives or false negatives or just generally not work, and they're not very good at differentiating if you have lots of cables near which ones are which, and on certain cable types they don't work very well, so sheathed cables and stuff, they can misbehave. But they are useful for certain specific applications. Anyway, I am going to glue this together and I'll get back to you in a second. And there we go, I have glued the button in one end, I have glued the coil on the other, and all the guts are inside the tube. It obviously does not look amazing, but it is functional and that's all that really matters. As you can see, press the button and it will indicate when you're near a live cable. It works much better now that it has a metal housing on it, because the metal housing provides a much better capacitive earth reference, which has fixed the sensitivity issues I was showing when I showed it functioning out with the case, because it relies on you holding the tube. You capacitively provide an earth reference for the circuitry, which is how it manages to draw that tiny current out of the mains wire. Yeah, I think that's basically everything. Fairly simple project, good start to people, useful tool, but use it correctly, don't misuse it. Thank you very much for watching, and I will see you in the next one. Remember to like, subscribe, the usual things. Yeah, and I will see you in the next one. Bye.